the test are going to be this. One of these 5 types will be the bearing question you get. And there's only one bearing. You're each going to get one bearing question. All right, so a plane flies 1.7 hours at 140 miles an hour on a bearing of 30 degrees. They drew the picture for you. So this is one of the ones where 0 is straight north. So remember, there's 2 ways to calculate bearings. And this is the one where straight up north is 0 degrees. So this is 30. And then that's 120. They've drawn the picture for you. So what we just have to calculate our distances and put those on the picture. So 1.7 hours for 140. So that means that's 238 miles. So this right here is 238. And then it turns and flies 2.9 at the same speed. So 2.9 times 140 is 406.
I already checked this and it's a 90 degree.
Yeah, it is.
So Pythagorean theorem.
Right. So let me, but just so everybody understands, yeah, you can use Pythagorean theorem on this one. On why it's a 90 degree angle.
Up and down is 180.
Yeah, these are just north-south lines. They really don't have anything to do with your picture, but they're north-south lines. So because of that, you can continue that line, and that means this right here has to be 60 degrees, because that's a 180 degree angle. And this is 90, which means that that's 30. So this is 30, because that's a parallel line cut by direct transversals. So 60 and 30 is 90. So it's a right triangle. So you use Pythagorean theorem to find your missing side. I have no reason to believe that if you get this one and the drawing is done for you, that it is not a right angle. You should probably check just to be sure, but I get that this measurement on C is like 470, about, it's like 470.6 miles. So if you get this particular one like this, you probably want to check to be confident, but I'm pretty sure that's going to be a 90 degree angle. Okay, so then the second one where they drew a picture. So it's the same basic idea. They've given us 26.6. For how long? What does it say?
The speed and...
At the same time. So, 4 hours. It's down here.
Oh, okay.
I forgot that it was. So 26.6 times 4. So the first one is 106.4. That's 78.4. And if I subtract that, this is a 90 degree angle. So I can use Pythagorean theorem to get my C value. Again, I have no reason to believe that if they give you this one with this particular drawing, that yours is not also going to be a right angle.
132?
132.16. Are y'all okay so far? So, if you get one of the two that has a drawing, you might want to check, but probably the angle up here is a 90 degree angle, and you can use Pythagorean theorem. All right, so then the next one, they don't give a drawing, and that's where things get a little bit more challenging. So you have to kind of draw your own drawing to make sure that you're getting things in the right place. So this is, which kind of bearings? This first one. Okay, so this is the so I've got, it's saying southeast of 50. So I have to draw a north-south line first. Oh, pretend that's straight. That's terrible. And I'm going to put an A here because my first move is to go south to C. So I'm going to put another north-south line over here. And then this is C down here. So A to C. So because it's southeast, that's this measurement from going south to moving east. So this is 54 degrees. And then from A to B is 82 east. So here's B. So this measure is 82. Again, anytime you have these, you can draw any north-south. You can also draw any east-west lines you want, if you wanted to do that. So the question is, how the distance from A to C. So this measurement right here, from A to C. Well, if I were to complete this triangle, draw myself an east-west line like this, I could figure out that this triangle, I could make myself a 90-degree angle. That would make this little piece 8. That would make this piece of this right triangle 82. That would make this missing piece, I could find that easy. I say that, I can type the right thing.
And isn't angle C 54 as well?
Yes. Because of the parallel lines cut by transversals.
44, 82, and 54.
44, 82, and 54.
Mm-hmm.
Okay.
Plane's flying at 250 miles and it takes 8.8 hours to go from A to B. Multiply that.
Yes, yeah, get your distances. 250
That's
times
from A to B. We need to find A to C.
250 times 3.8, and that's the only distance they give us?
Yep.
Law signs.
50. Yeah. So, yeah, you can use law of sines because I have this measure. It's 82.
Wait.
Wait a minute, hold on.
B to C is 36 south. Oh, wait.
Oh, wait. I knew that. Hold on just a second. I forgot. We had a south measure. B to C is 36. I didn't even put that, did I?
Me neither.
B to C. Oh, I messed my picture up. See, that's the hard part.
Yeah, redraw
Dang
that.
it.
I'm lucky.
I need a bigger piece of paper.
I'm just going to write it on.
Yeah, I'm just gonna go with that.
Yeah, write it on the desk. I'm going to draw it on just a separate piece of paper. Oh, that's for sure.
We need 3 lines. We need 3 pair of
I
lines.
actually, when I do these myself, I actually draw a whole bunch of lines, and I draw a whole bunch of east-west lines also, because it helps me keep it all straight.
Grid.
Yeah, makes it easier. Okay, so I'm going to put A, so we go down and up from A, don't we? Let me make another. No. Oh, pretend that's straight. That's terrible. I'm terrible at drawing straight lines. Okay, so we go from A to C, southeast. So that would be, I'll call this C. And that makes this measurement 54. Okay. And then
I assume A to C
from
is
A to
close.
B,
Is C the close one?
it doesn't matter.
Oh, does it not?
Well, I mean, you just gotta get the basic idea. From A to B is, so let's see, this is, call this B. That's, this measure is 82 degrees. And then from B to C, yeah, southwest, that works.
Can you move it?
That's a terrible, that's 36 degrees. Okay,
Can you move it in frame?
oh, sorry. Okay, so now this is 180 degrees. So that makes this missing piece, I'm going to write these in color so now I can see my inside of my triangle. That makes this piece inside of the triangle 44. Okay, so now I can draw east-west lines wherever I want them to be, and figure out missing pieces. So this one I think is the easiest one to help me. If I draw this east-west line, well, this one, pretend, then I have a triangle. Well, that's not a very good drawing. But this is, I can draw an east-west line, and this is 8 degrees, and this, to make a 90-degree angle, is 36 plus 8.
We know.
Which makes this 46, which makes this 90.
Oh. Well.
But I can't use Pythagorean theorem because I only have one measure, so you're going to have to use sine or cosine. Cosine, I used cosine when I did it earlier. Okay, so which measure do I have?
You have the one that goes from A to.
I have A to B because I need A to C, right?
Yes,
and A to B was 950?
Yes.
Okay, so if I need A to C, so I have the hypotenuse. And so if I need A to C, well, since I wrote this one in red, I'll just use cosine. I need this piece, and that's going to be the adjacent piece to that 44. So I can do cosine of 44 equals x over 950, and then multiply both sides by 950. So I would do 950 times cosine 44.
How do you get that, 46?
This one. So over here, I have that the 82 degree angle, and then if I draw an east-west line off my 82 degree angle, then that means my other angle of that triangle is 8, which makes this one 8 also. Like, it's kind of hard to explain. I drew a better picture earlier.
Okay, that one wasn't that bad. We
No,
like
it's
the
not gonna
90 degree angles.
I drew a better picture earlier.
After getting, the hardest part is getting the triangle drawn.
I mean, once you get the triangle drawn, you can figure it out.
I'm gonna save my bearing problem for last.
Yeah,
I'm gonna
But
save my
see-
bearing and my trig identities fine.
If you make a,
I can see it.
it's hard to do it, but if you, I did it earlier, I don't know. But if you, so this is 82 degrees, and you can draw an east-west line anywhere you want to. So if I draw this east-west line, and I know that's 82 degrees, then the remaining piece is 8.
Oh,
Yeah,
You know what I'm saying? So this is 90, which means you can get this piece. So,
okay, yeah.
does that make sense?
Yes.
Because you can draw in an east-west line anywhere. You can draw in a north-south line anywhere you want, and an east-west line anywhere you want. If it helps, it makes sense. So, okay, we got another one we got to make a picture of. And I actually drew this one. This one actually I have over there. This looks better. Okay, so bearing of a city A to B, 38 degrees. Okay, so again, I'm going to just draw some north-south lines. We're going A to B, and then B to C. This one's very similar to the other one. Okay, so here's A. Northeast to B. Bearing from B to C is southeast, so I'll say this is C. All right, so northeast, this is 38 degrees. This is 52 degrees. And we want to find A to C, so we want to find this. They gave me 55 times 1.4 is A to C. So this is 70, wait, from A to B. 77. And then 55 times 1.8 is 99. Okay. So again, I don't know, like, this kind of, I don't know. Looks kind of look like it could be right angle, but I don't know that for sure. But I can for sure, if I wanted to, draw an east-west line across here. That would make this a 90-degree angle. That one's 38, so I could find this one. That makes this 52. That makes this 38, which makes this 90. Which means you have Pythagorean theorem again.
Move it up.
Mm-hmm.
Okay. Wait. What?
Okay,
Sorry,
so
I draw
that's okay.
this thing confusing.
So this is
So
this is what I got. This is what I started with. Was this 38 and this 52?
And 52 is on, because you're going south.
Right, it's southeast. So
52
it's
is
52 outside, like
outside.
outside of. Well, it's in my triangle, but it's not the whole angle of the
Right,
triangle.
so it's,
But you could look at this 2A. This is a parallel line. These are two parallel lines cut by this transversal. So if this outside piece is 38, this piece is 38.
right.
So that 38 and 52 makes this a 90-degree angle,
Oh, okay.
which makes it Pythagorean theorem again, because this is a
Do we know
hypotenuse.
any of the other two angles?
I could find them, but no, not right now.
Okay.
But if that,
And
but
then we
if
have a distance of 77 on,
77 on, so you're looking for the hypotenuse again.
So wait, does that mean the entire time?
52.
It's
It's 90.
it's 52, 90, 38.
It's Okay. Yeah, my other picture's better. That I drew earlier.
Oh, because 52 is gonna be over here.
If
So my first angle is 38.
Uh-huh.
My second angle from B to C is 52. Parallel lines cut by transversal makes this 38 and this 38. So 38 and 52 makes this 90. So I don't know for sure that this is straight. So, but I do know that that's 90. So this is the hypotenuse. This was a different. I had different. It was a different problem, but it was the same setup. So I have different
also
measurements.
say, if that part's 52, then that top part of C is also 52, which would make
Yeah, this is
Which would make
this is
it
52,
38.
38.
which would make this 38.
Which would make the other side 52. So it's gonna be 30. It's gonna be 90, 52, and 38. Either
Yeah.
way. Okay, so we can just do. Which one are we gonna do? Tangent 52.
Well, you can just use Pythagorean theorem because you have the legs.
Oh, well, that does work as well.
I mean, you can use sine, cosine,
I
or
made
tangent
that
if you want to.
I was making that a little bit too
So,
complicated.
so maybe that's why that one is missed so much, because all of the other four use Pythagorean theorem. The only one that you had to use a trig one was the one
Maybe
that,
people forget.
that people miss
Maybe
maybe
people
so.
forget
to try a
to
trig
try.
thing.
Yeah.
So just know if you get the
The
one
one
that
that
is
does it
the,
really fine.
if you get the one that's the airplane, that, was it the airplane or the ship? It was the airplane. If you get the one that's the airplane, that's the one where you're going to probably have to use a trig.
No, we used.
We did? Which one did we?
Oh wait, no. The first. Okay, so the plane that you have to draw yourself.
Yeah, the one that you.
You have to draw.
Yeah, not the first plane, but the plane that you have to draw yourself.
Okay, so
if you get the plane that you have to draw yourself,
Okay, use
you're
trig.
probably going to have to use trig
Okay.
and not Pythagorean theorem.
And did
But all of the others, I think you can just use
Did you
Pythagorean
get?
theorem.
Did you get 125.4 on this also?
Yes.
Just making sure.
So just be careful about where you put your values and make sure whether or not you're looking for the hypotenuse or you're looking for a leg.
Yeah.
But other than that, you're going to have a right, you should have a right triangle unless you get the airplane that you have to draw yourself. All right, so let's move on to these identity problems.
Oh, fun.
Okay, so as far as what you don't, okay, this is the formula sheet. This is the exact formula sheet that you'll have. So all of these, you don't have to know off the top of your head. The ones you need to know are the Pythagorean, the reciprocal, you kind of know those anyway. The three Pythagoreans, the reciprocals, and the even-odd identities. Now, even-odd identities are pretty easy to remember. If you remember, even means you could fold the graph in half. Odd means you could flip the graph over. So cosine is even. Sine is odd. So what that means is if they give you, and it makes sense if you just think about it for a second. If they give you cosine negative theta, that means if I'm looking at a graph of cosine, whatever I get over here is going to be the same as it is over here because you can fold the graph in half. So cosine negative theta equals negative cosine theta. I'm sorry, cosine negative, that's wrong. Cosine of negative theta equals cosine theta. Because the y values are the same when you fold the graph. So it doesn't matter. But sine is the opposite because it's like this.
Negative theta is negative sine.
Yes. So cosine or sine of negative theta equals negative sine theta. Okay. If you can remember those two, then just remember every other even and odd one or go with it. So is tangent even or odd? Can you fold tangent in half or can you flip it over?
Flip it over.
You can flip it over, which means it goes with tangent. So it's going to be like this. Tangent negative theta equals negative tangent theta, not the cosine one. Okay? So same thing for cotangent, because you can flip it over. The secant and cosecant ones, one of them you can fold and one of them you can't. So one of them flips over and one of them folds. Hold on, they go opposite of. So this is cosine. So this one, which one goes with cosine? Secant. Secant can be folded. So secant goes with cosine and oh, that makes sense.
Sine versus cosine.
Yes, that makes sense. So, with all that said, the reason I said that is because this first one, woo, if you can see all that, it has you have the negative cosine. So, first of all, And we actually talked about this a little bit in 7th period because I hadn't ever brought it up before. So you know how when you type your calculator, it automatically, when you type cosine in your calculator, it automatically puts the parentheses, and you cannot back this up and put the squared in between the parentheses. It doesn't work. It'll give you an error. So if you needed to square something on your calculator, let's say it was like cosine of 30, it was cosine squared 30. Like it was written like this. It was written as cosine squared 30 degrees. If you want to type that in your calculator knows that when you close the parentheses, you mean the entire cosine, so you would do cosine 30 squared, like that. And there is that problem. There's a problem that you can just type straight in your calculator and get the answer. So that is the same thing as this, the way we write this. Okay? So when you have this written like this, I'm going to rewrite it for just a second as 1 minus cosine negative theta squared over 1 plus tangent negative theta squared. Now the reason I'm doing that is it doesn't matter with cosine because cosine is an even identity, and so cosine negative theta equals cosine theta. So this is still going to be, the top is just going to be 1 plus cosine. I could write it as cosine theta squared or cosine squared theta, it doesn't matter. But on bottom it does matter because tangent is an odd identity. So that means tangent negative theta equals negative tan theta. So that would be 1 plus negative tan theta squared. But if I square negative tan theta, it's positive. So I just want to make sure you don't mess your signs up. So I end up with 1 plus cosine squared theta over 1 plus tangent squared theta. Now, 1 plus tangent squared theta, that's an identity.
Which is
secant squared?
Secant squared.
And then is that negative sign on top?
Yep. This one could be negative sine theta, sine squared theta. What is secant?
1 over sine.
It's 1 over sine. So if I flip this,
Oh, it's all going to equal 1.
of course 1. So negative 1.
Negative 1.
So let me write that out for anybody who's confused, since I'm recording this. So I have negative sine squared theta divided by secant squared theta, which would be negative sine squared theta divided by 1 over sine squared theta. Oh no, see? It's 1 over sine squared. Oh!
So it's going to be...
Secant is cosine.
Oh,
Wait,
It's cosine.
it's cosine.
that's depressing.
So it's, then I keep switch flip negative sine squared theta times cosine squared theta. And you get, and it's multiplied, so you cannot replace those with 1. It's just sine squared theta times cosine squared theta. They just told us in the instructions to make sure that we have no quotients left. So that means no division. You don't want any more division bars, but you can have multiplication. You can have addition, and one of these in just a second, it ends up with addition still in it and stuff, as long as they don't have any, this next one. I'm going to write it on a separate piece of paper just because it's not very big on there, so everybody can see. I think, okay. Right. Okay, so I have, and it tells you in the instructions, write each expression in terms of sine and cosine and then simplify so that no quotients appear. So they started out with secant theta minus cosecant theta. It's cosine theta plus sine theta. All right, if it's already in terms of sine and cosine, you can leave it like it is. If it's not, you write it in terms of sine and cosine. So secant is
1 over cosine.
1 over cosine theta. Cosecant is 1 over sine theta.
You can put theta. You put the theta with the
The theta goes with the word.
word.
All right, so now I have to FOIL this. So
So it's gonna be,
So 1 over cosine times cosine is
It's just
1.
1.
Sine over 1 over cosine times sine
is tangent
is tangent. Because it's sine, it would be sine over cosine.
plus
Now,
cotangent.
cosine over sine is cotangent. And then negative 1 over sine times sine,
That's gonna be negative.
negative 1.
Okay.
Now my 1 and my negative 1
Cancel.
cancel, and you're left with just tangent theta plus cotangent theta. And that's it, because you have, it's just theta, nothing is, no quotients.
Negative 1 over sine times cosine is negative cotangent or
Oh, it is negative cotangent, you're right.
not? Okay.
This one should be negative. So it's tangent theta minus cotangent theta, sorry. Because those cancel.
Sine over sine is negative 1. Alright. That wasn't that bad.
These are actually turning out okay.
Yeah, they're not too bad.
Why are these?
Okay, so
these-
cosine of t,
You can put theta.
yeah, me too. I prefer, because it starts to look like cost. Okay, so cosine of theta, secant theta minus cosine theta. I'm going to turn
And they want us to
secant
write it
into
into-
1 over cosine theta
Right.
minus cosine theta. Then distribute.
Oh, this is gonna be terms of property.
So that's going to be cosine theta over cosine theta minus cosine squared theta. Well, cosine theta over cosine theta is 1
1
minus cosine squared theta, which equals
sine.
sine squared.
Is it 1 plus sine squared is cosine squared?
It's sine squared theta plus cosine squared theta equals 1.
Oh, so it's
So-
1 minus cosine.
Yeah, 1
squared.
minus cosine squared is just
Oh.
sine squared theta.
Which one is it where it's like 1 plus something? Is it secant?
Secant and cosecant are both 1 plus. 1 plus tangent squared and 1 plus cotangent squared. Which we're about to use in the next one. All right, so the next one is 1 plus tangent squared. I'll write it down since this is. So 1 plus tangent squared
Which is
it's part of an identity, yes.
which is
Secant squared theta minus 1. Yes. So the identity itself is secant squared theta equals tangent squared theta plus 1, but that's the same thing as this.
Yep. So it's just secant
So
squared
I can replace
over.
the top with secant squared theta.
Well, you can also change that to 1 over cosine.
So I can, and I will in just a second do that.
With both.
But if you look at this, secant squared theta minus 1, if I move this plus 1 over, that would be secant squared theta minus 1. So this is tangent squared theta.
Whoa. Okay.
All right, now I'm going to write them. I'm going to write it horizontally. Secant squared is 1 over cosine squared theta divided by sine over cosine, sine squared over cosine squared.
So
Because
this
that's
turns into
tangent.
cosecant.
So then I can keep switch flip.
So 1 over cosine squared theta
Times cosine
Cosine.
squared theta over sine squared theta.
Cosines cancel.
My cosines cancel.
You're left with secant.
And I've got 1 over sine squared theta,
You just want to write it like that, right?
which is, actually, they don't want quotients, so you're going to go back and put it as cosecant squared theta.
Fuck, these aren't so bad if you know.
The only thing you just have to be careful of on these is we went through a lot of steps to get to cosecant squared, but because this is on the computer, if you get to 1 over sine squared theta, you did the whole thing right, but then you accidentally put secant squared, you missed the whole thing even though you did all that work right.
Yeah.
And that totally stinks.
That's
So
crazy that
be
that,
careful.
that one equation can just be simplified.
I know, can go all the way down to that. It is weird. All right, so if you have one like this one, this next one, secant,
I mean, because then that means like literally everything's a trig identity.
oh, it pretty much, yeah. Secant, pretty much is. Secant I'm going to say theta. Secant theta minus 1 over secant theta. Anytime you have one like this, the whole goal is to get them all together, which means you're going to have to find a common denominator. So right now, this is secant over 1. And in order to put them together in one piece, I need this to have a secant on bottom. So I'm going to multiply that first fraction by secant over secant. So now I have secant squared theta on top over secant theta minus 1 over secant theta. Now I did that so that I could go ahead and subtract. So that's going to be
Secant theta minus 1 over secant.
secant squared theta minus 1 over secant theta. And secant squared theta minus 1, we just dealt with that, is tangent squared theta.
Nice.
So tangent squared theta over secant theta. And then we can do what we did just a minute ago. Tangent squared is sine over cosine. So I'm going to write sine squared theta over cosine squared theta. That's tangent. Divided by secant theta.
I'm going to turn to cosine over cosine.
Yes. So I can do sine squared theta over cosine squared theta divided by 1 over cosine. And then keep switch flip. Sine squared theta over
Wait, is it sine? Wait,
secant.
is secant squared?
It wasn't squared. So, because it was always 1 on bottom. It was the first secant was squared, and that's where I got the tangent squared. But my second secant wasn't squared. So when I flip this and make it multiplication and cosine theta on top, I have 1 cosine theta to cancel with one of my cosines on bottom.
That's weird.
So this is going to cancel with one of these, but not both. Which means now I have 2 sines on top. So sine theta,
Oh, so it's going to be tangent sine.
yeah, over cosine theta. Which means I have a sine theta and a tangent theta.
Okay. I was thinking like, wait, was secant squared? Okay.
Okay. All right, so same idea on these. I need a common denominator. So right here, I need, so 1 over secant squared theta plus 1 over cosecant squared theta. I need to get a common denominator. So the only common denominator could be is secant squared theta, cosecant squared theta. So I'm going to add it, I'm going to actually multiply that cosecant squared theta on this one and secant squared theta on this one. So that means I have cosecant squared theta over the common denominator, cosecant squared theta, secant squared, plus secant squared theta. Add across the top, and that gives me cosecant squared theta plus secant squared theta over cosecant squared theta, secant squared theta. That's a mess. Now,
Are we going to key switch flip?
we can.
Okay.
So, I'm going to write it.
Maybe we should have just left them separate.
You can. It's going to be the same either way. So I can write cosecant squared theta plus secant squared theta. I'm going to put that in parentheses because divided by cosecant squared theta, secant squared theta. Now I'm going to write that as, it's going to be, I can probably do this all in one step, but I'm not going to, just to not confuse anybody. I'll still write it as, that's going to be 1 over sine squared theta, cosine squared theta. Then I can keep switch flip, cosecant squared theta plus secant squared theta times sine squared theta, cosine squared theta. which, by the way, obviously, there's a lot of these steps you could skip. I just don't want anybody to not know what I'm doing. I don't know, Cole. Hold on.
This is all going, oh, this is going to turn.
So this is 1 over sine squared theta plus 1 over cosine squared theta times sine squared theta cosine squared theta. So now if I distribute this,
It's going to turn to sine.
so what happens when I do sine squared theta cosine squared theta times 1 over sine squared theta?
It's going to turn to 1.
Not quite, because this has got sine squared and cosine squared.
Oh.
But the sines will turn into 1.
Plus cosine squared.
One, it'll just be 1 cosine squared. So if you multiply,
Oh.
it ends up being sine squared theta cosine squared theta
And then
over sine squared theta
cancels out.
plus sine squared theta cosine squared theta over cosine squared theta, which means your sines cancel, your cosines cancel, and now I have cosine squared theta plus sine squared theta equals sine squared theta plus cosine squared theta?
It was 1.
1.
That's an identity.
It equals 1. Yep.
Oh. I was like, where did you get the 1 from?
That was a lot. That one was a lot.
There, let's just memorize like every single trigonometry.
This one isn't bad.
So you
This
don't have to-
this next one isn't bad at all, honestly.
Thanks.
Whenever it says 1 minus cotangent,
Yeah.
and it says multiply and simplify, they want you to write it down twice and FOIL it. So 1 minus cotangent times 1 minus cotangent. And then we FOIL. 1 times 1 is 1. 1 times negative cotangent is negative cotangent. Minus cotangent. Plus cotangent squared. That would be 1 minus 2 cotangent theta plus cotangent squared theta. Well, if we factor it, we get right back where we started. So, simplify.
Wait a minute. This one's kind of confusing.
Well, cotangent squared theta is, oh, I guess it would simplify it. Cotangent squared, what does cotangent squared theta equal? Anybody remember?
1 plus cosecant.
Yeah. Oh, that doesn't help us though. 1 plus cosecant squared. That doesn't really help us.
I was gonna
I mean, I think I
You could
multiplied
turn
and
them
I'm
into, like,
simplifying.
You could turn them into cos.
You could turn them into tangents. I mean,
You could, well, you could do cosine over sine, but that's not going to help much.
I just don't know what they want us to do. What do they want us to do? Did I multiply it right? 1, 1, minus 2, yeah. Oh, that's all right.
Is that it, really?
Well, I'm just trying. There has to be a way for it to get simpler, maybe. I mean, cotangent squared is secant squared. Is cosecant squared plus 1. But that plus 1 doesn't help me. That just makes that. Oh! No. Because they don't want us to solve it. They just want us to multiply and simplify. It doesn't simplify. I guess we multiplied and simplified. We multiplied and then we added those two together and we simplified. I'll go back and look at the answer for that one and see in just a minute and see.
So it's cotangent squared theta minus 2 cotangent theta.
Theta plus 1. Yeah. I mean, because if you factor, you get right back where you started, so I don't know why you would do that. I don't know what they want us to do. I'll go check the answer in just a minute, if it's on there.
This next one is going to be.
This next one, okay. So,
1 plus sine x is,
Negative.
it's not squared, so.
oh, never mind.
So I have to get a common denominator. The good news is, though, actually, it's going to end up as an identity because I have to get a common denominator, and this is all one piece, and so is that. So I have to multiply this by this and this by that. So
1 over 1 minus cosecant, sine squared theta.
so my new first fraction is going to be 1 minus sine theta. Sine theta, or I put sine x this time. If you multiply this bottom out, it ends up being 1 minus sine squared theta.
Which turns into 1 over negative cosine squared theta, which is
So
Negative secant
this
squared.
piece is going to be 1 plus sine x over 1 minus sine squared x. So if I FOIL these out, 1 times 1 is 1. The two middle terms cancel out. Sine times sine is negative sine squared. So now I can subtract across the top. Do not forget when you subtract across the top. This negative goes to both pieces. So it's 1 minus 1, so that's nothing, and negative sine minus sine.
Which
So-
would be negative 2 sine.
Negative 2 sine x over 1 minus sine squared x becomes cosine squared x.
I feel like that top part's an identity. Oh,
Um,
I'm thinking of two double.
Well, it could be, yeah, it kind of looks like a double angle identity, but I could turn this into negative 2 tangent x secant x, because this is negative 2 sine x over cosine x cosine x. So there's two of those,
Yeah.
right? And then that first piece is 2 tangent, and the second piece is secant.
So your final answer is
This. Because remember, you want no quotients in your final answers, no fractions.
so even if you have to make reciprocals and stuff, it's
Yeah.
better than
Then leaving, yeah,
okay,
than
one
having
sec-
fractions.
1 second.
Okay. You're good.
Oh, not for all solutions.
That's okay. We got this. Okay, here we go. So, solving the equation for all solutions on the interval of 0 to 360. Okay, from 0 to 360. So we're just going around the unit circle one time. 2 sine theta plus 1 equals cosecant theta. Okay, so the problem is I can't solve this until I have one trig function. And right now I have 2. So I need to try to get this all in terms of one thing.
Reciprocal
So
of cosine.
I'm first, I'm going to turn to my cosecant. So I'm going to leave my 2 sine theta plus 1 alone, and I'm going to turn this into 1 over sine theta. Now I'm going to move everything to one side and get a common denominator. So 2 sine theta plus 1 minus 1 over sine theta equals 0. Now all of these things need to have a sign on bottom so that I can make it all one thing. So I'm going to have to multiply each thing by sine over sine. So my first piece becomes 2 sine squared theta over sine theta. My middle piece becomes sine theta over sine theta minus 1 over sine theta equals 0.
What would be sine theta squared?
Which one?
The last one.
No, because I already had a sign on bottom, so I don't have to multiply it by sign.
Okay.
I already had the denominator. All right, now I'm just going to add across the top. That would give me 2 sine squared theta plus sine theta plus 1 all over sine theta equals 0. Minus 1, thank you. That would have been a bad mistake. Equals 0. Now I can clear the fraction, and when I do, it just cancels that sine theta. So if I multiply both sides by sine theta, 0 times sine theta is 0. So now all I have left is just this trinomial, which you're just going to factor. If it's easier, like I think it's easier to just write it down with x's and just factor it like you would factor anything. And it's just easier for me. So I'm going to rewrite it as 2x squared plus x minus 1 and just kind of factor it because it's simpler. So 2x squared plus x minus 1, factor however you know how, x squared plus x minus 2, that's x plus 2, x minus 1, bring the 2 back. So my factors are x plus 1 and 2x minus 1. So now I'm going to put the sign back. And so it would be sine x plus 1 and 2 sine x minus 1. Both of those get set equal to 0. Those are your two factors. I'm going to set them both equal to 0. Now, solve each one of them separately. So I'm going to move the one to the other side. So sine x equals -1, and 2 sine x equals 1 sine x equals 1/2. Now you got to get x by itself, so you're going to arc sine.
Good lord.
So if I arc sine this, I'm asking myself, where does sine equal -1? It only happens in one place. Where does sine equal -1? And it's on the interval of 0 to 360, so in degrees.
It's gonna be at 9, but all the way down to 270.
270.
So it's,
And then I arc sine this, and it is asking, where does sine equal a positive 1/2? That happens twice. Sine is positive in quadrants 1 and 2.
60 and 120?
30.
Oh, wait, what? 30 and 150.
30 and 150. So there's your 3 answers. You okay, Megan? Yeah? Okay.
4 of those.
The next one.
I just took up an entire page writing on that one thing.
The next one is tangent theta minus 3 cotangent theta equals 0. So first thing I'm going to do is write cotangent as 1 over tangent. So tangent theta minus 3 over tangent theta. Again, we got to get a common denominator. So you're going to have one on there that you're going to have to get a common denominator. I'm pretty confident. Which means I got to multiply this first piece by tangent. The other piece already has the denominator, so you don't have to multiply it. So it's going to be tangent squared theta over tangent minus 3 over tangent theta equals 0. Yeah, add them together. So now you have tangent. Oh, this one's actually pretty easy. So now you have tangent squared theta minus 3 equals 0 over tangent theta. Clear the fraction. Multiply both sides by tangent theta. And that leaves you just tangent squared theta minus 3 equals 0, because 0 times tangent theta is just 0. So move the 3 to the other side. Tangent squared theta equals 3. I don't want tangent squared. I need tangent. So you take the square root. So that gives me tangent of theta equals square root 3. Now, when you take a square root,
It's positive or negative?
it's positive or negative. So,
So it's going to be like every single quadrant.
yeah. So, I arc tangent this.
So it's going to be 60, 120,
60, 120, 240,
and then 300.
and 320.
Right.
No, 300, you're right. I can't subtract. Because it's all the 60-degree angles, because tangent is square root 3 at 60. Okay. That one wasn't that bad.
There we go.
This one's not too bad either, actually. Because, okay, so when you have one like this one, cotangent squared theta minus 4 cosecant theta equals negative 5. All right. I can't answer this until it's all one thing. But there is an identity that relates cotangent and cosecant. It,
Is it equal to 1?
it's cotangent squared equals, no,
1.
cosecant squared. It's cosecant squared equals cotangent squared plus 1. Which means that cotangent squared equals cosecant squared minus 1. Right? If I just rearrange this. So that's what I'm going to do. I'm going to move this over here so that it's cotangent squared. So that I can take this out and put cosecant squared theta minus 1 in the place of that cotangent squared. And then I have minus 4 cosecant theta, and I'm going to move my 5 over because now I know I have to factor this, plus 5 equals 0. Now combine like terms. I have a -1 and a plus 5. So that's cosecant squared theta minus 4 cosecant theta plus 4 equals 0. Now you just factor this. So if it helps you, like it does me, to rewrite this as x squared minus 4x plus 4, you're looking for factors of 4 that you add to get -4. That would be x minus 2, x minus 2. So I get cosecant squared. Actually, I could probably write it. It would probably be better if I wrote it as x minus 2 squared, like that. So it would be cosecant minus 2 squared equals 0. So cosecant theta minus 2 equals 0. Cosecant theta equals 2. So we have to arc cosecant that. Or is everybody okay so far? All that gibberish. Arc cosecant. I just wrote cosine, and I didn't mean to. Okay, so the problem is I don't know that stuff. So instead of doing arc cosecant with this as 2 over 1, I could switch that to 1/2 and do arc sine. Because sine and cosecant go together. So then it's just asking, where is sine 1/2?
30 degrees.
So, and are we in, 30 degrees and
150?
150, because it's positive in quadrant 1 and quadrant 2. That wasn't so bad. One more that uses the same identity, and that's the last one. And it'll be on this one. So I have cotangent theta plus 2 cosecant theta equals 8. Okay, so the identity that I know that relates these two, everything is squared. So I need to square these things, and it's easier to square them. It'll work if you just square it like this, but it's actually easier to square them if you'll separate the two functions. So I'm going to move because this has a coefficient, I'm going to move the cotangent over so that it's going to be 2 cosecant theta equals 8 minus cotangent theta. And then I'm going to square both sides. Now, don't forget you got to square the coefficient. So it's going to be 4 cosecant squared theta equals, and then this you have to FOIL out. So it's 8 minus cotangent theta, 8 minus cotangent theta. That's going to be 64 minus 16 cotangent theta plus cotangent squared theta. All right, this time, everything over here is in terms of cotangents. So my identity that I wrote down just a second ago, where are you? Choking to death. Which is cosecant squared theta equals cotangent squared theta plus 1. I now want to change, I'm going to change my cosecant into cotangent squared theta plus 1. Ooh, that's my identity. I'm going to change my cosecant into cotangents because these are all already cotangents. So,
It's going to be 4 cotangent
4.
squared theta plus 4.
yes, because they have to distribute the 4. So it's 4 cotangent squared theta plus 4 equals 64 minus 16 cotangent theta plus cotangent squared theta. I'm going to move everything over to this side and factor, and I'm going to rearrange it while I do that. So it's going to be cotangent squared theta. I move this over so it's now minus 20 cotangent theta. Move the 4 over, so it's going to be...
Wait, it's cotangent squared.
The first is. Oh, you're right. Ah, dang it. Thank you. 0 equals, so that's going to be... Oh, so I can move the other way. Yeah, move the other way. So that's going to be 3 cotangent squared theta. Move that to this side, and that's going to be plus 16 cotangent theta. Move that to this side, and that's going to be minus 60. Oh, Unfortunately, it doesn't, I can't divide by 3, can I? No. So you can try and factor it. Does it factor? Factor to 180 that you combine to get 16. Does that work?
Lose 90. 90, 10.
Nope. I don't think so. I don't think it factors. So you have to use quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a.
Look at song.
Yeah.
Plug that all in the calculator.
Plug that all into the calculator. Find the solutions. Make sure that, and so what you're going to end up doing, because we're in terms of cotangent, is you're going to end up arc cotangenting this.
Cotangenting.
Yeah.
Great word.
So, and just make sure that you stay on the interval of 0 to 360. That one's, I hope you don't get that one,
Please no.
to be honest.
Please, I don't remember.
'Cause-
Just remember the song.
I don't even know the song.
Oh, well go listen to it a few times.
You guys learned that last semester?